All right, today we're going to look at something called permutations. So we have a question. We're wondering how many sandwiches can we make when we have 2 types of bread to choose from, 3 different types of meat, and then 2 cheese options. A basic way to answer this question would be to start a tree diagram. So we have white and wheat bread, and then off of each type of those breads, we have our 3 different types of meat. So we have ham, turkey, and roast beef off each of those. And then off each type of meat, we further our tree with American and cheddar cheese as options. So we have a white sandwich or white bread with ham and American cheese, white bread, ham, and cheddar, white bread, turkey, and American, white bread, turkey, and cheddar, and so forth. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different sandwiches that could be made with our options. Another way to find that out would be to take our 2 types of bread times our 3 types of meat times our 2 cheeses to get our 12 options. And that leads us into something called the fundamental counting principle. So if we have independent events, our number of outcomes can be found by just multiplying them. And independent, remember, means they don't affect one another. So our previous example, the type of bread we chose did not affect what meat we chose, and what meat we chose did not affect what cheese we chose. So we could multiply all of our options together. Here's another example. If we're at a restaurant and they have 4 different main courses and 5 different vegetable options, we want to know how many meals could we create using 1 entree and 1 vegetable. Well, our entree does not affect our vegetable, so we would just multiply our 4 times our 5. We could create 20 different meals. How many one-topping pizzas could we make if we had 2 types of crusts and 4 different toppings? I want you guys to answer that question. Okay, when the order that we choose something or arrange something matters, we call that a permutation. Okay, for example, if we were planting a flower garden and the order that we planted our flowers mattered based off of color. So a red, white, and pink flower is different than a white, pink, and red flower. So the order that we planted matters. So that would be what we call a permutation. We'll go back to that in a minute, but in order to understand permutations, we have to know what a factorial is. And a factorial is when we have a number and multiply it by every single number below it. And factorials are represented by an exclamation point. So this says 5 factorial, and we find it by taking 5 times 4 times 3 times 2 times 1. We always stop at 1. We never multiply any negative numbers. So 5 factorial is 120. So here's an example where we would need a factorial. How many ways can we line up 7 different people? So if you think about 7 spots that we need to fill, for that first spot, we have 7 people. Once we choose that first spot, we have 6 people for the second, 5 people for the third, 4, 3, 2, 1. That's the definition of factorial because we would be multiplying each of these options. So we would have 5,040 ways to arrange those 7 people. Okay, we can get in with a little different kind of math in factorials. We have 9 factorial divided by 4 factorial. So I'm going to rewrite this 9 factorial over 4 factorial in a different way. So remember, 9 factorial is 9 times 8 times 7 times 6 all the way down to 1. Okay, so I did 9 times 8 times 7 times 6 times 5 times 4 factorial because 4 factorial is 4 times 3 times 2 times 1. So all of this still is 9 factorial. I wrote it this way, though, because our denominator is 4 factorial, so now I can cancel those 4 factorials off of the top and the bottom. And that leaves me with 9 times 8 times 7 times 6 times 5, which is much easier than typing all the rest of that in your calculator. So you get 15,120. I'd like you guys to try 7 factorial divided by 5 factorial. All right, back to permutation. Remember, permutation, the order that you choose objects matters. So we have n objects, so that's our total number of objects chosen r at a time. And it's denoted like this. So n, p, r, that p stands for permutation. So n objects chosen r at a time. And here's our formula for it, n factorial over n minus r factorial. So here's kind of a word problem where we would use a permutation. There's 6 people in a competition, and we want to know how many ways, that should say the people, how many ways can the people finish in first or second? So clearly first is different than second place. So the order that we finish does matter. So there's 6 people total, and we're choosing the top 2 people. So 6 and then permutation 2. So we plug our numbers into our formula. So 6 factorial over 6 minus 2 factorial. Order of operations says simplify those parentheses, so we get 6 factorial over 4 factorial. And I'm going to rewrite 6 factorial as 6 times 5 times 4 factorial over 4 factorial. Those cancel. We have 6 times 5, which there are 30 different ways that those 6 people could finish in first or second place. Here's another one of those flower questions. So your grandma's planting her flower garden, and she has 5 different colors of flowers to plant in the first row. However, the first row of her flower garden only has room to plant 3 flowers. So we're wondering how many ways can our grandma plant her flowers? So we have 5 total options, and we're going to choose 3 of those options to put into our flower garden. So here's kind of the work. Comes down to 5 factorial over 2 factorial and simplifies to be 60 different ways Grandma could plant her flower garden.